Hey guys, this is Mr. Quinones. We're going to do an exploratory exercise into trig functions. So first, let's go to the bit.ly IM2 website. And first, let's just watch this. You just watch it and then do it yourself after. So in the bit.ly, we're going to go to chapter 8. And then we're going to go to 8.2. So, Mr. Fletcher has created this really cool GeoGebra with my deeper understanding of trig functions. So, what we have here, we have a triangle right here. And you could change its hypotenuse length, and it's a right triangle. You can see that right here. The maximum we can make it is 6 inches right now, just so it could fit your screen, but this can go up unlimited. And you can also change the reference angle. The reference angle would be this angle right here. That's 90. This is the reference angle, and this is the other angle. So you can see you can change the angle. Okay. So, for example, let's go to 30 degrees. At 30 degrees, with a hypotenuse of 6, the opposite length is half of 6, which is something we studied before. The short leg is half of the hypotenuse. And as you can see, if you increase it to 40, then this is getting taller. And also what we drew here was a comparison of the hypotenuse, 6, and the opposite leg. So you can see what percentage it is. So these numbers over here are showing you, drag it a little further up. Okay, so it looks like this is definitely more than half. So the sine of 40 degrees, we should have a 40 right here, is equal to the opposite length, which is this, 3.85, divided by 6. So it's the proportion of the opposite divided by length. That gives you a percentage. So it would be 0.64, or you can say that's 64%. So the red, the opposite length of the 40-degree angle, is about 64% of the hypotenuse. So you want to really think about as sines as being percentages. Okay, so you can see this right here. I think we can even like right click. I guess you can't right click here. We can just move it here. So if you look at a 10 degree, 10 degrees is a very short opposite length, because only 10 degrees. So if you divide the opposite 1.04 divided by 6, you're going to get 17. So this is 17% right here. See that the hypotenuse does not change length. And conversely, if you go to a very large angle, 75 degrees per se, the opposite now is getting really close to the degree one with length right there. So if you divide that actual length by that, you'll get 96%. So this is only on opposite and hypotenuse. So the trig function that deals with opposite and hypotenuse is called sine. See, I did them in colors for you. Excuse me. And you can see it's red over green, opposite over hypotenuse. It's a fraction, which turns into a decimal, and the decimal is actually a percentage. So notice how if I change the length of the triangle, just make it real small, the proportions go down exactly the same, and you still have the same percentage no matter what. That's why trig is basically a proportions problem. So this triangle right there, this little very tiny triangle, is similar to this bigger triangle. And this can go up millions and millions and thousands and hundreds of times bigger. The proportions will stay exactly the same for a 40 degree. Okay, so kind of play with that when you finish watching this. So what you want to do is pause it right here and make yourself some notes. Pause right now and write down some notes about sine and what does it mean. It's the opposite over the hypotenuse. Okay, next is cosine. And cosine, and now we're dealing with the adjacent angle. We call it the next to, not angle, next to side, it is blue, next to the angle, divided by the hypotenuse. This is also a percentage. Right now we have the adjacent at 4.0 and the hypotenuse at 5.75. If you divide those two, you can get 0.70, which means the blue line is about 70% of the green line. So the adjacent side is about 70% of the hypotenuse when it's 45 degrees. And as you increase it, this one kind of goes the opposite way of sine. See, remember sine as the increase of the, look at sine. When you increase the angle, the red one is getting taller. Well, in cosine, it goes the opposite way. As the angles increase, the cosine, which is the side next to the angle, it's actually getting smaller because it's kind of the reverse. And as the angle is getting smaller, the percentage is getting bigger. Keep an eye out over here as I make a smaller angle. So basically it looks like the angle is collapsing, okay, which makes the bottom, the flat part, longer. But the triangle could be a different position. It could be standing up. So it's not necessarily the flat part, but it's more of the adjacent side. Okay. So write yourself some notes about cosine and pause it here. Next is tangent. Okay. So tangent is the relationship between the opposite length to the adjacent side. So it's a fraction of opposite on top divided by adjacent on the bottom. So there's no hypotenuse involved here. So right now we have 1.04 divided by 5.5, and if you divide it, you get 26%, which is saying that the red line right here is 26% of the blue line. So if you stack 4 of these on top of each other, you'll get to the blue, okay, give or take a few degrees. So with tangent is a relationship between the opposite side and the adjacent side, no hypotenuse. Now watch what happens as the angles increase. The opposite side is getting taller. Let's look at it right now. 30 degrees. The opposite is 57% of the blue. See, this one is 57% of that. As the angle is increasing, they're getting, now it's 70%. Okay, and at 40 degrees, we're at 83%. And at 45, they are exactly the same. So their relationship is 100%, which is 1. 100%. The red is 100% of the blue. They're identical. And then as you keep on increasing, now the red one is taller than the blue one, and it's 119%, which means it's 1 and 19% more. You keep on increasing. You see the red's getting taller, the blue's getting shorter, opposites getting taller. The angles are getting increasing. Okay, and later on we'll explore a sine wave. Okay, right here, look at that. So at 80 degrees, the opposite is very, very big compared to a very small adjacent, which makes 5.6, which means it's 567%. So the red one is a lot, 500% of this one. So you gotta get this times 5. And then if you go to 85, 11, so it'd be, this one is 1,100%. 110%. No, it's 1,000%. And then if you go to 90, well, the red one is, there is no blue line. See, there's no adjacent because there's basically one line straight up. And then if you go the opposite way, we go all the way to 0. Okay, so write yourself some notes right now about tangent and how it relates to opposite divided by adjacent. Notice how opposite length is on top, adjacent to the bottom. Cosine, it's adjacent over hypotenuse, and sine is opposite over hypotenuse. Write yourself some notes on tangent. Okay, next it's time for some exercises. Okay, so I have a couple of GeoGebra exercises open here. Let's see if I can make you some quick problems to do. Now the question you guys have, most kids would have, is when do I use sine and when do I use cosine and when do I use tangent? Well, you could resolve that by saying if, for example, if, just pretend this number wasn't there, 3.9 was not there, but you knew 4.4 and 40 degrees, then you could figure out the opposite side with tangent, because the relation, the proportion would be the same for any triangle. Okay, all right, so let's just practice a little bit here. Let's see if I can get the right one open. Okay, let's see. Okay, so here's a triangle that has a hypotenuse and it has a missing adjacent and a missing opposite. So let's suppose that we want to know the blue line. Okay, so we want to know the blue line, the adjacent, but we know the angle. So you have two pieces, and you want the last piece. So what you'd want to do is find out what is the adjacent over hypotenuse of 50 degrees. Okay, so you can use your calculator, and you can use this one too. Okay, adjacent, and then you want to go and change this to 50 degrees, and that number is 64% right there. So here is the equation right here. Cosine of x is 64. So if you go back to this guy right here, you can draw this out, and you could write. You get a writing program going. Okay, so you would say, okay, I can use cosine because it has adjacent and hypotenuse. You say the cosine. Let's see if we can get this thing working. You say the cosine of 50 degrees is adjacent, which we're going to call it x, we don't know, divided by 3.5. So this number is in calculator, the cosine of 50, but you could also get it from over here. The cosine of 50 is 0.64. And one thing you could do, so you're going to replace this number with 0.64, and you could even do this. This is also 0.64, which is 64 over 100. Like if you got okay, so 64 over 100 equals x. So you want to get x by itself, and if you multiplied, this side by 3.5,